Hello and welcome everybody. My name is Yigit Boyar and I'm the technical lead for architecture components. Hi, thank you. So today we are going to talk about what is new in architecture components, but before we start with them, let's look at what we have been doing in the last 2-3 years. So 3 years ago, we were talking to developers, and they were saying, oh, Android development is so hard, so hard. Or like, what is hard about Android development? And they started listing things like lifecycles, persistence, and like a lot of things are just hard. So we needed to pick something. We said, OK, we're going to first create an architecture guidance, and we're going to tackle some of the major problems we think are important. So we started with lifecycles and persistence. So 2 years ago at I/O, we announced them. Soon after, we have added paging because we realized people struggle with that, making it efficient. And then in last year's I/O, we have added work manager and navigation to the fog. All these 5 libraries together had more than 150 releases in 2 years. There's like a release every 5 days. And based on the latest survey, 70% of professional developers use one of those libraries in their applications. So thank you. So this is a very amazing adoption number for us. And let's look at how we are doing it. So every project starts its life with an early access program. So once we know what we're planning to do, we send it to some developers, ask for feedback. After we are comfortable with that feedback, we release a public alpha, which is when we are still developing it actively, but it is ready to show everyone. After some time, we become happy with the functionality and the APIs, and we call it beta. When we call something beta, that means the API will not change anymore. So you can write code, and that code will still keep compiling. And eventually, the library becomes stable. And soon after a library becomes stable, we always go back to alpha and then beta. So this cycle keeps turning. We heard that many people are unhappy because everything is in alpha all the time. This is because of it. You can happily use the latest stable version, but we want to develop in the open, and we want this rapid iteration cycle. And all of this is possible thanks to the community. So we do a lot of user experience research. We talk to developers. They keep these developer diaries while they work. They do regular work at work. They log what they are doing and tell us how it is going. We do a lot of one-on-one interviews with developers to better understand the problems. We do early access programs so that before showing it to everybody, we can talk to a closer group, more in depth, and get initial feedback. Issue tracker, where you report your bugs and feature requests, is very important for us. This is what we use to prioritize features and bugs. Last but not least, we closely follow things like Reddit, Stack Overflow to see what the community is thinking. So yesterday, we have announced that it's going to be a Kotlin first for Android. So this means we are not going to just release KTX libraries. We are going to release more Kotlin-focused libraries. Maybe some of them will be written in Kotlin to take advantage of the better language features. So that means some of the APIs will first target Kotlin, and then we'll also support the Java programming language. So during today, in this, when you talk about these new features, you will see a lot of Kotlin. OK, so let's start the libraries, and we'll start with the oldest library we have, data binding. So if you don't know data binding is our declarative UIs inside XML. It tries to bridge the gap between your code and your XML. So if you have a layout like this, if you put these layout tags around it, you'll get a binding class. If you add variables as inputs to that layout, they become setters and getters in this binding class. And then you can use these variables in your layout and declare what you want to show, and data binding takes care of showing it. This last 1 year, we've been heavily focused on the tooling part of data binding. So we have significantly improved the compilation speed. It's now 20% faster while we run the annotation processor. We added support for distributed Gradle cache so that if you're using it in your company, you benefit from your peers compiling the project. Last but not least, in 3.5, now we have an incremental annotation processor for data binding. It's experimental, so you need to turn it on with this flag. So please give it a try and let us know how it works. So other part of data binding is tooling integration, which is Studio. So we did a lot of work here. So one of the things we've improved is how the live class generation works. So on the left here, I have this binding class associated with the layout on the right. And if I want to access this text view, I can just go ahead and then give it an ID. So when a view has an ID, it becomes a field in the binding class. And here, immediately, without compiling the project, I have that field in that binding object. So you don't need to wait. And so, but if you're using data binding, this is not how we update the views, right? You can also do it with a variable. That's actually how you would do it in data binding. So we go ahead, change it. We add this header as a variable to the layout. As you can see, all autocomplete works. We get rid of the ID because we don't need it. Instead, we are just going to say text is header. As you can see, code completion works here too. On the left, it immediately turned red. So just go ahead and fix it. So all of this works without waiting for compilation. So another important thing is refactoring. So I have a user object here on the left, which is a variable on the right. And in one of the expressions, I access that and call a function on that user object. Now, if I go to the class and say, I'm going to rename this function, and I'm going to call it, say, combine name. So as soon as I make this change and hit enter, Android Studio updates my binding abstraction automatically for me. And you can do the same thing from XML, and it will update your code. Last but not least, we know data binding error messages has been a huge problem. That like you will have any problem in your compilation, you will get 1,000 errors. So we fixed that problem. We have also added a section in your output that's specific to data binding errors, so you can easily discover them. So, similar to data binding, like how do we access views on Android? Let's look at all the options we have. We're going to evaluate them in terms of elegance, the compile time safety, and the build speed impact. So first, we have the good old find view by ID. It's not elegant, it's very verbose. It doesn't provide any compile time safety. You don't know what type you're receiving, but it doesn't have any build speed impact, so that's good. You could use data binding, which provides a very nice API with the compile time safety, but it runs an annotation processor, so it does slow down your build. You could be using Butterknife. Similarly, it's another annotation processor, so it's going to slow down your build. Now, if you're in Kotlin, you could use Kotlin synthetic accessors. It provides partial compile time safety. It's a very beautiful API, and also it doesn't have any build speed impact. But we are looking for this, like something that has a green check mark in all of these things. It should be possible. And we don't need to look far to discover this. So if you look at this data binding, we see a lot of people using data binding like this. They put IDs to the views just to get this binding class on the right. No variables, no expressions. So what do we just call this? View binding. So view binding is a new feature. It's going to be available in Android Studio 3.6. That's the next version. So now let's go back to the previous example. We had these layout text. They're not necessary. We don't have variables. So we can get rid of it. It's just a regular layout XML. So if you had it from our activity, we will access it like this. But you don't want this find view by ID, so you can throw all of it out. And instead, we can use the generated binding class to inflate it, and then set the content view. And now we are going to have all of the views with IDs as public final fields in that object. So you get perfect compile time safety, because if the ID with the correct type doesn't exist, your code will just not compile. And you can also use it from Java. Thank you. So all of these binding classes are generated by the Android Gradle plugin. So it doesn't need to do any extra work unless you change a layout file. And if you change a layout file, only that file gets invalidated. So it's very fast during incremental compilation. It is 100% compile time safe, so if your code compiles, you know those views exist in the right layouts. It has full studio integration similar to what I have shown for data binding earlier. And speaking of data binding, it is completely compatible with data binding. In fact, if you're using data binding just to access views, you can turn it off and turn on view binding, and your code will compile as is. OK, now we're going to move to Lifecycle, and I'm going to invite Sergey to tell us more about it. Thank you.
Thanks, Yigit. Good morning, everyone. My name is Sergey, and I will give a quick update on lifecycles. So what we did 2 years ago is, first of all, introduce the way to observe events from your fragments or activities, so you know where started or resumed, and so on. We introduced view models, that is, retained state across configuration changes, kind of a starting point for your non-UI code. And lastly, live data is just observable, but have a good default behavior to observe with Lifecycle. But before proceeding to new stuff, we have to talk about that. After I/O, I read on the internet this, and I was like, what's going on? I don't agree with that at all. And I have to explain now like why this confusion exists and why it's not true. So the picture it's kind of like that. So it's going to be a fluffy explanation at the beginning. So you have your stuff. You put your stuff into your view model or a save state. Configuration change happens. You go to your view model or save state and grab your stuff out of there. Is it a similar mechanisms? Well, actually, no. So let's take a closer look only on save state part. Same setup. You put your stuff into the save state. When we talked about configuration change. Well, actual purpose of save state is not configuration changes. It is created to help you with process dev, because system, when your application in the background, may decide, well, we need this memory for some other task and kill your application. But because Android wants to provide nice user experience, what we do is once your application is restarted, we give you hints, the save state is with hints to you, how to recreate the state that you had before and the user seen before. So how does it actually work? And then one step deeper. So once you put your save state, once you have this save state, what actually happens, save state travels to the system server. System server is a separate process, so there's like this travel across process boundaries. And this gives us very specific restrictions on what is a save state. It's not a stuff. It's a data. It's parsable data. It's just what we call serializable in Android. So, or primitive types. And also we have this data limit on the size of it, because otherwise, well, system can't keep like gigabytes of data per every application. And serialization actually takes time as well. So it just won't work. So this is a save state, so let's take a look on the view models. Well, in a contrast to save state, view model always live in the process memory. It never leaves it. So configuration change doesn't affect it anyhow at all. It just, memory is continuous, your view model is still there, process doesn't die, so your stuff is there. So, however, when the process is restarted, well, it's in process memory, process dies. Everything there goes away. And when your application is restarted, from a view model perspective, you have nothing. So you can see they handle different situations. And view model are for like keeping references to your non-serializable things like network requests and flights or database queries. Well, it doesn't mean that you actually have to write these things there, but it kind of provides the scope for them. And other things that you can keep there is big objects like a long list of data you query from database and you need to keep somewhere, or images that are relevant only for that fragment specifically. While save state is this UI-based like selection and scroll state and navigation state. This is like more interesting for us. What does it mean? So once you show, let's say, a screen with user profile, you want to know what user you showed last time, so you need to keep user ID in this navigation state. So we will see this example in a second. So as you see, vModel and save state work together. They shouldn't like be opposed. So let's see on this user example. So your vModel will look like this. You have a user, and then you have a live data of this information. How you would do this vModel plus save state in an old way? Well, as you see, it's fairly boilerplate. In onCreate, you go to a bundle, plus the information from a bundle, down plus to vModel. On save state, you go in reverse, fairly boilerplate. And what we did, we introduced a way to contribute the save state from vModel right away. So now you can receive this save state handle object right in your vModel constructor. And this object will allow you to access save state right into your vModel. So what is this? It's very simple. It's map-like object, meaning that it has a very straightforward API. You just put stuff and get it. Once you put it, later when your application is recreated, your model is recreated, it receives the save state handle. The information that you put by the key will be available to you again, so you can query by the same key. We also give you a nice convenience API. If you use live data, you can, instead of just get data, you can observe it in a usual way. And because save state is mutable, because otherwise it would be constant, no need to save it. We give you mutable live data, and you can write as you would do it usually. So last slide on this theme is provided by my manager, actually. Save state is not your database. No matter which API you use, old, onCreate, and onSave instance state, or this new convenience API, or fragment arguments, underlying mechanisms are the same. So you still have these restrictions about what you can put there on the size limit, so it won't just work. And we go to our theme. So Kotlin is everywhere. Lifecycle aren't exceptions. Yesterday, we had a talk about coroutines in Lifecycle. If you missed it, you can find it on the internet. We introduced a bunch of new APIs and looking for feedback. And we kind of paid our depths on other fields of lifecycles. For example, SAM conversions were broken for a long time for live data. So you can see it doesn't look like natural Kotlin code. And now it does. You can have this lambda after observe call. Similarly, transformations looked very unnatural because we have a static method on transformations. And it's just not the way you do that in Kotlin. Instead of that, you have extension functions. We did that. And last thing is vModel initialization. We kind of force you to have this late init var, and it's a bit of a code smell. People get worried when you see it. It's for a reason. Or nullable vModels. So now, instead of that, with property delegation, you have very concise syntax. You just initialize your vModel, and that is it. And actually, that is it for lifecycles. And I hand out for Sumir, who is going to present a work manager and update on it.
Hi, everyone. My name is Sumir Kataria, and I am an engineer on the Android team. I want to talk to you a little bit about Work Manager today. For those of you who don't know, Work Manager is a background processing library for work that is specifically deferrable, meaning that it doesn't have to be executed right away. This is also work that's persistent, so it can go across app restarts, it can go across device restarts, so it needs to be persistent. This is work that's constraint-based, so you can have work that only triggers when you have a network connection, for example, or other constraints. And finally, this is work that's backwards compatible. So it goes all the way back to Ice Cream Sandwich API 14. Before I go to actually top priorities, we released a stable version of Work Manager 1.0 a couple of months ago. So I want to thank everybody who participated in the alpha, beta, early access program. Thank you very much. So our top priorities moving forward, there's 3 of them that I'm going to talk about today. One is performance and compatibility. The next is testing. And finally, building for the future, so things that are more forward-looking. So let's talk about performance and compatibility. The first thing that I want to talk about is on-demand initialization. It's available now in alpha, so please check it out. So one of the things that you might have noticed with Work Manager is that it needs to be initialized when your app starts up. This is more or less a hard requirement currently, and this on-demand initialization will allow you to start Work Manager only when you need it, which is really good for avoiding critical hot paths like app startup. This is not something that you need to worry about anymore. You can just use it when you actually need it. Let's take a look at how this looks. So right now you might have your application class. You might have customized it so you have a My App. And in Work Manager 2.1 alpha, you can extend or actually implement configuration.provider, override this method, and this returns a Work Manager configuration. So this is all Work Manager needs to know on where to get this data. Now, currently in Work Manager 2.0, you get workmanager.getInstance, and you don't provide any arguments. Starting in 2.1, if you provide this context argument, this is Work Manager signal, OK, if I'm not initialized, I can go to the application object, get the configuration, and do a lazy initialization when I'm needed. So that's all it is. It's very simple. The second thing I want to talk about here is Google Play Services integration, and this is coming soon. So this basically will allow you to have better performance on pre-Marshmallow devices, and it's totally optional. You don't really need to integrate it if you don't want it, and if you do want to integrate it, it's just a simple Gradle dependency that you add, nothing else, because there's no API changes. Under the hood, it'll see if you have Play Services. If you're using it, it'll use it on pre-Marshmallow devices. And compatibility improvements. This is an ongoing project for us, and this is not something that you'll necessarily see in our code base or in our releases, but it's stuff that we do behind the scenes, and I want to talk a little bit about it. So we've noticed that there are a few differences in devices and manufacturers. For example, if you go to the recents of your device and you swipe away an app, on a stock Android device or on a Pixel device, you'll notice that the process gets killed. But on some devices, you might see that the app gets force stopped. And force stop is a really destructive action. In the case of force stop, your jobs get stopped and wiped out, actually. Your alarms get wiped out. You no longer receive FCMs. Force stop is a very destructive action. So we're working with the OEMs to have a consistent app close behavior here. We want to make sure that everybody has the same app close behavior, which is really good for libraries like Work Manager, which operate in the background. The next thing I want to talk about is testing. When we launched Work Manager a couple of months ago, we kind of had a problem with Roboelectric support in that it didn't work. We fixed it. It's out and stable. Sorry about that. And also, now we have in alpha unit testing for workers. So basically, you can create your workers using one of these 2 classes, test worker builder or test listenable worker builder. And you can just use them by using the do work or start work method as is appropriate. So let's take a look at that in action. So let's say you have a work request. You can use a test worker builder, and you can say, create that work request from a given context and a given executor on which it will run. You just build it. So this gives you a worker class back. And then you can call the do work method, which is a method you've already overridden, to do and get its result. You can assert the result. You can check the state of your app, make sure everything's fine. So that's how you would unit test a worker. If you're using a listenable worker, same thing. You start with a work request, and you use a test listenable worker builder, and you can say, create a worker using that request. You build it. And same thing, instead of calling do work in this case, you call start work. Remember that that listenable workers are asynchronous and control their own execution, so you don't need to specify an executor here. And start work returns a listenable future, so you just call a blocking get on in this case, and you assert that everything is the way you want it to be. You can even provide more arguments, so you can say something like, here's the input data for it, here's the run attempt count that you're currently on, here's the tags that you have for this worker. And the last thing I want to talk about is building for the future. And this is, in particular, we want to have foreground service support in Work Manager. And this is very much in progress, so this is not ready. This is later in the year. You'll probably see something about this. But the basic idea is that what if you could do work in the foreground using the Work Manager API? And this is particularly useful. I was just talking to someone this morning. They wanted to do a long-running upload. Work Manager and Job Scheduler both give you a 10-minute slice of time to do an upload or whatever work you have. But what if it goes longer than that? You can use a foreground service for that, and Work Manager can make it easier for you. So because this is a foreground service, your app will show a notification. Talk to us about it in the sandbox if you're interested. We want to hear what everybody has to contribute to this, what use cases you have, and so forth. And now I'd like to turn it over to Danny for Room.
Thank you, Sumir. Hey, my name is Daniel Santiago, and I'll be talking a little bit about Room. But before we get to what's new at Room, what is Room? Well, Room is our SQLite object mapping library, and it basically creates a bunch of code for you based on some annotation so that you can easily access your data objects with a SQLite database. Let's do a quick recap on how this looks. Imagine we're making a music application. We're going to be saving some songs on a database. We start by having a data class. We call it song. It has some ID, a URL. For Room to know that you want to have a table for this entity, you annotate it with the entity annotation. You let it know if it's unique identifier. Now, in a database, if you want to get the data out of it, you would write a normal SQL query, select star from son. But to let Room know that you want to link this query with that data class, you actually put it on a method that returns a list of songs, and it's annotated with that query. Now, you don't throw these methods all over the place. You actually put them on what we call a data as a subject. And if this is just an interface or an abstract class annotated with @DAO. Now, to link these together, you have your music database. It extends Room database. It has a database annotation. And then you let it know of its entities, which in this case will be the song. And the DAOs are just getter method. In a nutshell, it kind of looks like this. You have your database, your DAOs, and your entities, and your application interacts with all of these three. Now let's get to the good stuff. So something new that's in Room 2.1 is Coroutine support. In Room 2.0, if you try to add a suspend method to your DAO, because you have a Kotlin app, you're using coroutines, and you probably want to do your heavy work asynchronously, you usually add your suspend method. Room would freak out. He wouldn't know what to do. He would, nope, can't do that. And this might let you to create wrapper methods that are suspend functions that actually then call the actual DAO function. But you can imagine this doesn't scale very well. But no worries. In Room 2.1, you can actually have DAO methods that are suspending methods. Room will generate the correct code, including using a background dispatcher. You can also have suspend methods with insert, update, and delete. And even more so, you can have suspend implemented methods that do multiple database operations that are annotated with a transaction so that these database operations are done atomically. Even more so, there's also an extension function on Room database that will allow you to start a transaction. It creates this special coroutine context that you can use to also perform multiple database operations. Now, another new feature we added in Room is full text search. Full text search is an extension in SQLite to be able to create tables to efficiently search for data. Thinking back on our music app, imagine we're trying to create a search functionality. We want to search for songs given a phrase. If we were to do this in Room 2.0, we would have to write a DAO method kind of like this. Doesn't look great. You have this huge where clause. It has all the columns. It's not great. But no worries. In Room 2.1, if you want an entity to be able to be backed by an FTS table, you simply use the FTS annotation. And now this greatly simplifies your query because you can start using the match expression, which is way more efficient. Speaking of, yeah, thanks. Speaking of simplifying things, database views is another way to simplify your database operation. So database views are kind of like tables, where everywhere you will reference a table, you can reference a view, but they're different because you cannot insert data into views. To put it differently, they're kind of like queries with a given name. Let's think again back to our music application. This time, we want to show a list of albums, and these albums have some aggregated information, the total number of songs, and the total time in the album. And thinking back how we started using Room, we have a simple data class with the information that we need. Now in Room 2.1, instead of having a big query, you can actually annotate your data class with a database view, and instead of making a table, it'll create a view out of it. And then to specify how we get this information, you put your big query in the annotation. And you can see it's a big query. It has aggregated information. But the important thing is that now you can use this view or entity as if it was another table. And you can see here we also have another order by, which makes your operations easier. Nice. We've been also adding more support for Rx in Room, since we know people like Rx. In Room 2.1, you can have insert, update, and delete method that return completable, maybe, and single. And even more newer, we also added support for returning Rx type on query annotated DAO methods that perform write statements, such as update, insert, and delete. So for those queries that are more complicated, that you still want to use Rx, you can do that. Now, that's some of the new things in Room, but we still have a lot more work to do. One of the most immediate things we want to do is have an incremental annotation processor. This will greatly improve the build performance for those of you using Room, or for those of you who might start to use Room. We also know that relationship is another area of improvement. We only have a single annotation for at relation, and it helps you with one-to-many, but we feel like we can do many-to-many, even maybe using a jump table. So that's one area we are trying to explore. We also know that migrations are not so great. Like when you use Room, it creates the tables for you, but then when you migrate, you also have to call the create statement. We feel like most of the migration operations can be done with some code generation, such as adding a new table, renaming a column, things like that. Last but not least, as we take a look at Kotlin and coroutines, we're keeping an eye on their APIs, and we'll be able to add support for channels and flow. Thanks. So back to Yigit, who will be talking to you about paging.
Thank you. Thanks, Danny. OK, let's talk about paging. So if you don't know paging, paging is our library to load large lists into a recycler view lazily. And it works with multiple data sources. It works with Room, RAM, Retrofit, whatever kind of place where you can pull the data from. So for the next version of paging, our focus is on networking and error handling. So we heard this loud and clear that it's kind of hard to channel your errors from your network layer back into your UI. So we are working on a new pipeline to enable this. We'll also add support to change those pages as you pull them, so you can inject headers and footers or filter them. Last but not least, we are going to improve the support for RxJava and add support for coroutines. So these are all in the next version of paging. We are about to start an early access program for it. So we are doing an early access program because we significantly changed the API, so we want to get good feedback. And later in the summer, you should expect an alpha version. All right, navigation. Navigation is a library we released in previous I/O. It helps you with your in-app UI flows. So you can easily show a graph, control how the user should navigate, etc. So a couple months ago, navigation became stable. And we already started working on the next version, which is already out. And in this next version, we have a new feature for view models where you can scope them to a navigation graph. This is amazing when you have things like sign-up flows that's composed of multiple screens. You can just have one view model for that whole scope. Another feature is you can now navigate by a URI, so you don't need to have the IDs. And you can finally use dialogues as navigation destinations. So these are all in 2.1. But another big upcoming feature for navigation is support for dynamically delivered modules. Now, it's not ready yet. It's going to take a couple of months to implement. But it's going to be available in navigation so that you can just navigate as if everything is inside the application without thinking about dynamic features. So to learn more about all of these, join us later today at 1:30 in the Jetpack navigation talk. OK, so if you're maybe new to these things or trying to get started with Kotlin, trying to get started with architecture components, we just released a new course on Udacity. There's a 10-course session completely online that teaches you how to write a modern Android application using Kotlin and architecture components. So it's a great resource to get started with these technologies. You can always find detailed documentation on our website. And if you want to be involved further in our process, you can go to this URL and see how you can participate in our development flow. Thank you.